Zipping stuff. Right click, okay, here's your MATLAB folder, right click, new, compressed file, zip file. So you could just type, it's got a different MATLAB. It's got a different extension. So you right click anywhere, new, and compressed or zipped file. So this is one file, and it contains, for example, an entire directory. So I've got a zip file. I got the same name up here, but they're two different things. One's a zipped, and one's just a regular folder. And if I drag the regular folder over to my zipped one, it just copies. And why is this empty? That doesn't make sense. Okay, that one's not empty. You can take, let's go up here. So I'm in a different directory, actually. There. Here's my regular folder. Here's this folder here. So I can just take my regular folder, drag it over to the compressed folder, and it'll copy all the documents into the compressed folder. Click this. It acts like a regular folder now. It's compressed, but all your files, whatever files were in there, are now in your zip folder. So that's how you create a zip folder. You can put a whole bunch of files in one file, and then you can email it. That's the point of doing this. So when you're done with your with your MATLAB exam, you're going to have to take like a function file. You're going to have to command history, by the way. So let's go to command history, and well, I don't have anything there yet. I can use create a script. So next week I'm going to want you guys to you're going to write a function, and you're going to have a published script. And so I'm going to want you to show me your command history, your function, your command window, and you can do select all. You can copy the contents of the command window. There's another trick you guys might not have heard of yet. So this will start recording. Diary is a command. This starts recording all the commands that you do. And then when you go diary off, it stops the diary, and you can copy the diary then to, there it is. It just started diary over here. So when you're all done, you can then copy the diary. So that's your command window. That's your command history. Your figure, you'll need to know how to save a figure. Let's do that real quick. Now you can there's commands to load and save. The easiest way, well, look, here's your floppy icon, which we don't use anymore, right? This looks like a floppy, but we don't save the floppies anymore. So maybe they need a new icon. So you can save the figure here. You can do file, save as, or save, anyway. So your menu in the figure can save the figure. And I'm going to ask you to publish also. So you'll have a publish output. You'll need to be sure and copy that over. So there's several files that are requested for the exam next week. Your figure file, command window, command history, function, publish, and figure. So in case you screw up on the publish, then I can take a look at everything else you did. Okay, blank USB drive, your name on the outside, put a file inside your USB drive with your name in that file. Okay, chapter 3, on to chapter 3. Any questions so far? Okay, chapter 3, we're dealing with We're dealing with matrices, just like we did before. Now we're getting a little deeper. We saw how to input these things. So this makes a matrix. It's got 1 and 2 in the top row and 3 and 4 in the bottom. The semicolon causes a new line to be created. So I hit it. Oops. Ooh, it doesn't like that. I selected, by the way, you guys notice I selected the semicolon, hit return. Basically, it takes the selection and executes it. I didn't want to do that. I wanted to execute this stuff. So just watch out for things like that. It can happen. Format compact, of course, gets rid of extra line feeds so you can see everything. Now, by now, you guys should know how to multiply, divide, and so forth. So if we have b equals, we got to make it a 5:6. So 1 times x plus 2 times y equals 5. 3 times x plus 4 times y equals 6. That's the equation we're solving, 2 simultaneous equations. And the way we get the answer, a times x equals b. If we divide a into this side, if you're multiplying from the left, you got to divide from the left. And this is what Jethro Bodine would call the Gazinta sign. So it's a backslash instead of a regular forward slash. And do the same on both sides of the equation. This a cancels this a, so you'll find the solution to these simultaneous equations this way. If you have now matrices, you can do this, where this is the matrix and this is the vector. This is a row vector. This is a column vector here. This is a row vector here. You can also do this in matrices. So there's 2 different division signs, remember? Just keep an eye on that. So x equals a Gazinta b. That's your answer. So a times x should equal b. Let's find out what it is. It's 5 and, okay, yeah, it equals b. So I checked my answer, it works. This is, now you can go to many dimensions. You can go to 3, 4, you can keep going with this. And you learn a lot about that in matrix algebra. The formulas get horrid by hand, but they're pretty easy to do in MATLAB, which is why MATLAB is really popular with engineers. Eventually you guys are going to learn matrix methods. Sophomore year, junior year, something like that. This is how to use MATLAB to do that kind of work. Just for grins, I'm going to go, let's see. Yeah, let's try, now A would have to be flipped around because it's 1x plus 2y equals 5 and so forth. So if you did it by row vector, you'd have to, 1x, anyway, we'd have to transpose A. So transpose is that apostrophe symbol, remember? So we got this, and then we can do the second one here. B has to be a row vector, by the way. So B transposed equals BP equals B transposed. Okay. And we can do B divided by A now. And we should get at, oops, let's see. If I take a row vector, oops, I know what I did wrong. Okay, B is fine as a column vector. I'm sorry, it needs to be a column vector, so let's try that. Oh, I'm sorry, BP slash A. I was trying to do BP slash A. It's a transpose of B. There, the matrices work out. And if I forget to set the answer equal to something, if I do this, I get the answer. And I should be able to go XP star AP. And you know what I did wrong? I forgot to use AP earlier. Okay, let's go back up here. We want BP divided by AP. There we go. And XP equals that answer. And it's the same as it's transposed from what it was before. Here's the previous answer. Here's the answer this time. And now if we do AP times XP, we're going to get, why doesn't that work? Let's see. BP over AP equals, oh, I know what I did wrong. Okay. Order makes a difference in linear algebra. XP, it's not commutative. I can't multiply A times X. I have to do X times A in this case. When I've transposed everything, I have to do X times A. So, now most of the time we use this top form. In matrix algebra, in linear algebra, we do things this way. This is the standard way of doing things. That X and B are column vectors, A is your matrix. Generally, we don't do things this way, which is probably why I got a little confused, because it's kind of not what I'm used to doing. But you can do it. Okay, now let's get a big matrix going. We can get elements out of the matrix, and I'm going to create a new matrix. Okay, this is a big 3 by 3 matrix here. I can go A, parentheses, 1, comma 1. So that's the first row, first column. A, first row, second column. Row comes first. It goes row and then column. And then you can even get to higher dimensions. So I did first row, third column. I didn't do first row, second. I did first row, third. I just did a typo. Okay. If you want a range, for example, A of 1 to 2, so this is the first 2 rows, and I'm going to do second 2 columns. This colon says go through that range. So first and second row, second and third column. There we go. Which is right here, first and second row, second and third column. The upper right corner of the matrix. Of course, you guys have seen the transpose operator, just the single parentheses, and it switches rows and columns is what the transpose operator does. Let's see. You can set values. For example, let's do this. I can set that. Ones is a special matrix. It just fills it all with ones. So I'm going to put ones in the upper right. We're just going to put those 4 elements equal to ones.